welcome back. In our previous Take 5 episode, Understanding the Wave, we talked about reflection, the principles behind generating anti-reflective surfaces, and how these ultra-thin layers cancel out 99% of reflected light, offering uninhibited protection to artworks. Now I'm going to give some detail on the process by which anti-reflective coatings are made. Coatings can be deposited onto surfaces in a number of ways. Magnetron sputtering is a very adaptable method of thin film deposition, which involves the removal of atomized material from a solid by energetic bombardment of its surface by ions or particles. Sputter coating is used in the production of many now common items in our modern technological world, from semiconductors for phones and computers to solar photovoltaic cells capturing energy from the sun and low radiation architectural glass reducing heat loss. Next time you look in your car rear-view mirror, you're also probably looking through an enhanced transmission sputter-coated surface. Researchers sputter-coat specimens and samples in order to gain deeper understandings both of our natural and our man-made world. The conductive qualities of this gold sputter-coated ant, for example, will allow fine detail surface imaging using scanning electron microscopy. This technique can also help museum paintings conservators discover hidden details about artists' methods and materials. Here, for example, a very small paint sample cross-section taken from the artist's work seen on the left gives us a clear understanding of the layering of the artist's colours when viewed under magnification. Sputter coating the cross-section means we can identify the elemental makeup of a particular paint layer. So to move from the micro world of research laboratories to the macro world of manufacturing. Sputter coating happens at scale with Tru Vue. Our coating machine spans more than the length of a football field. Engineers in Minnesota have built and fine-tuned their multi-chambered coater over 30 years of continual development in the production of fine art optically coated materials. Manufacturing is fully automated from the loading of the material right through to the final product. Here you can see the large long tubes called targets that have been primed with elemental coating material, millions or billions of atoms thick. So what happens exactly, and how are these solid materials deposited to form the coating? Once the glass and acrylic substrates have been cleaned of impurities, they enter the chamber at atmospheric pressure. Air is then removed by vacuum pumps, and once very low pressure is achieved, process gases such as argon are introduced in order to maintain exact operational pressure. Strong magnet bars placed inside the targets are then flushed with cooling water and begin to rotate, generating a magnetic field. When high voltage is applied to these targets, the gas becomes ionized and a plasma forms, wherein free electrons hit the argon atoms, which become positively charged ions. These ions are continuously accelerated towards the target's negatively charged surface. And this bombardment means that the atoms on the target will be sputtered onto the glass or acrylic sheets steadily moving along rollers through the chamber below. So this is exactly what you can see happening here through this small viewing window into the sputter coating chamber, lit by the glow of excited ions relaxing to a lower energy state and emitting light. The properties conferred by the anti-reflective coating stack are inherent in the product and permanent. Being bonded to the acrylic substrate at an atomic level, performance will last for the life of the substrate, and beyond the 15 years of physical samples we have to date showing no noticeable change in performance. Accelerated age testing provides additional support, indicating a useful life longer than 100 years.